Hello everyone, welcome to my U Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is find unique binary string. So given an array of strings nums containing n unique binary strings, each having a length of n, you have to return a binary string of length n that does not appear in nums. If there are multiple answers, you can return any of them. Okay. So for example, here if we consider these two strings, what were the strings? 0, 1 and 1, 0. The binary strings that are missing here is 0, 0 or 0, 0, and another one is 1, 1 of length n. N here is 2. So you can return either 0, 0. It is saying that 0, 0 would have also been a correct answer, and if you return 1, 1, that would also be fine. Okay, so this is what you have to do. Now let's have a look at the constraints. So the constraints are that length of the string will be of order 10 raised to power 16, the strings in the given array, and all of the characters in the string are either zeros or ones. Okay, so basically, to solve this problem, what we will be doing is we will store all the strings in a hash set to separate only to quickly check that if we have seen a string previously or not. To quickly check that we have seen a binary string previously or not. And then what you can do is you can use recursion to find out all the strings of length n that can be generated by replacing 0, 1 or more characters in a chosen string from nums array. What I mean to say is, for example, previously we have taken example of this 0, 1 and 1, 0. Now this is your nums array. If let's say I pick this element and I have put these two in a hash set. These two I have put in a set or hash set. Okay, so if I select this one, which is 0 comma 0 1, now for each, let me quickly add a new slide. 0 1, for each of the characters in this string, we have two options. For each of the characters in string, there are two options. One can be that you can replace the character with 0, and another can be you can replace the character with 1. Now, if you are replacing the character with the same character that is it is initially, if you are replacing character with same character, then it won't have any effect or say any contribution in generating a new character at this place. This is, I think, a trivial thing to notice, but anyhow, I thought it would be good to mention it. So, let's say I replace 0 with 1, and with this one, let's say I wish not to replace it, and then you have this string. You can quickly check this string in the set that you made, or the set that you made that was having 0 1 and 1 0. So you can see that this is not present in the set, so you can easily return this as your answer. So this will be your answer as it is not present in the set. So this will be the approach. And if you ask what will be the number of operations that we will be required, so they will be order of 2 raised to power n, and n here is at max 16. So 2 raised to power 16. Let's see what 2 raised to power 16 is. So it's 65,536, which is of order 10 raised to power 5. or you can say 6 into 10 raised to power 5. So these number of operations will be required to solve this question via this solution or approach. Number of ops required, and these ops are lesser than order of 10 raised to power 8 operations limit, ops limit. Basically, if the number of operations required reaches equal to this limit or exceeds this limit, then you may get a TLE. Here you are well within the bounds of this limit, so your solution will be getting accepted. Okay, so those of you who are new to this limit concept, I will be providing a link of article describing how the time complexity of accepted solution varies according to input size. Okay, then you can explore this article and then you will be able to understand why we are imposing this limit. Okay, so and if you ask space complexity wise, it will be the space that recursion stack will be taking. Space complexity. So recursion stack will only take space that will be equal to the length of the string, and so at max you can have n elements in the stack, then they will be popped out one by one. Okay, and another elements will be pushed, so overall it will be order of n for recursion stack. And if you are also taking into account that asset that we have made, then also it will be of length n. So whether it's the given string in the nums array or whether it's the nums array, they are of same size as it's mentioned here in the constraints. So it will be of order n only. Okay. So uh, let's head towards the implementation part. So in this unordered set, we will be storing unique binary strings. And let's add the strings given in the nums array. Unique binary string dot insert num. Okay. So once you have added all the things for a quick lookup of duplicates, this will be for a quick lookup of duplicates. Okay, and then you will do what you will do is you will call a recursive function. to generate binary strings from any one of the string chosen from given nums array, and replacing the replacing each character either by 1 or by 0 in that chosen string. So let's say we chose the first character, first string that is given to us in the nums array. In the nums array, and we call the function. So let's call this function generate binary, and let's pass two arguments. One will be the string that you are choosing. So I am choosing the first string in the nums array, and also we will be passing unique binary string to have quick lookups. Okay. So what we will be doing is we will be modifying this nums. So to modify this nums, we will be making changes to it. Instead of generating a new string. Okay, so let's declare a private function and another private variable. As of now, it will be, let's say, answer. Initially, it will be empty string. We will be replacing it with our answer as we arrive on it. So void generate binary string chosen one, and unordered set that we have passed to the function call. Unique binary string. Okay, so if your unique binary strings is not having your current, or let's say this is the current string, instead of that, current string is a more appropriate term since we will be changing the string. So if your current string is not there in the unique binary strings set, then your answer will be current string. Okay, so here we are not taking any reference, we will be storing a copy. Otherwise, in the recursion calls, when you will be going back towards the popping out the stack elements, I think it will be changed. So it is wise to take a copy here. So okay, then we will return in this case. Else, if that's not the case, then you will keep exploring the options that we can. Also, I would like to mention that we will be storing some kind of index also, so that we can keep a track that which character we are trying to replace. So let's pass an index also. We will be starting from the 0th character. Let's call this start index. Okay. And if let's say this there is a case that you have reached the end of the current string, or you have exhausted the length of the current string, let's declare a variable length current string dot size. Okay, and then if you have exhausted this length, in that case what you will do is you will simply return from here. Okay, since you have not generated any unique string, otherwise you have returned from here, and if you are reaching in this condition and it's true, then you will simply return. Okay, and now you are having, or instead of start index you can also call it index. Basically we are doing replacement here only, so there is no issue in calling it a index. So we will do the replacements here and call make recursive calls. So the replacement will be, let's do the replacements in the first. Let's do the replacements. We will be storing the current character, the original character that is there. So current string and the original character at this index. Okay, then you will be doing the replacement. Uh, this is to backtrack our choice that we are currently making. That's why we are storing it. Then you will do the replacement current string. Let's say first of all I decide to go with 1. Then you will make a recursive call and generate binary current string and unique binary will be passed, unique binary set, and your index will be incremented by 1, obviously, since you are moving in left to right directions while doing the replacements. So then what you will do is uh, I think original character is not playing any role here. We can just you know uh, take another option of 0 here and make a recursive call. Unique binary string index plus 1. Okay, and if you want you can change it straight to the original character. Okay, I think that should give you your answer, and at last we will be returning our answer. Okay, now let's have a quick check whether we have typed something wrong or some typos are there or we forgot something. So unordered set will be storing unique binary numbers, and then we have populated the unique binary numbers set, and then we have make a recursive call to our function generate binary along with the index and the unique binary set and the chosen string. So if it's not there in the unique binary string set, then you will return and your answer will be updated in that case. And if that's not the case and you have exhausted all the options, then you will return simply. So I think this should be fine. And then I think that's correct. I think we should try to submit. Okay, there is a typo here. Unique binaries, no matching function. Okay, we have declared int instead of string. And there is a typo here also. Okay, as you can see, we are getting accepted solutions for the sample test cases. Let's submit for the final evaluation. As you can see, it's getting accepted for the final test cases also. And I think this is of no use here. Let's try to see whether we are right or not. Yeah, I think it was of no use. Yeah, it's getting accepted anyways. So this is of no use to us. Okay. So this is how we will be solving the problem. If you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.